Hi everyone, welcome to JavaScript Daily channel. Today we are going to talk about recursion functions in Python. First, what's recursion? When a function calls itself within the function is called recursion. An example, a program with recursion calculating factorial. According to the above program, it creates an object of factorial. Then using the object it calls the method factorial, and the method gets the value 4. Next, the else section executes the following, that's called factorial tree. Then else section execute, it calls factorial 2. Next, the else section execute, it calls factorial 1, and the else section execute again, it calls factorial 0. Now n is 0, it returns 1. Finally, we have 1 multiple 2 multiple 3 and multiple 4 equal to 24 is printed, and this value that are displayed on the screen. Like a factorial function calls itself again and again. Here we call two objects. One of them is the print 1 is equal to 1 according to the constant, and the next one we give the factorial number 7 that equal to 7 1 multiple 2 multiple 3 multiple 4 multiple 5 multiple 6 and multiple 7, that should be equal to 15 40. What's loop? Sometimes it's necessary to execute a block of code repeatedly. Program language provide a control structure called loop to execute a set of instructions. Loop execute a statement inside the block, one after the other. There are three types of loops, as while loop, for loop, and do while loops. An iteration also refers to a loop. But here we talked about difference between recursion and loop definition. Recursion is a method of calling a function within the same function. In contrast, loop is a control structure that allows executing a block of code repeatedly within this program. These definitions contain the fundamental difference between recursions and loops about speed, stacked condition, space complexity, code readability, and conclusion. First, we are going to talk about speed. Speed is a major difference between recursion and loop. Recursion executes slower, and however, loop executes faster than recursion. In stacked case, all parameters saved in recursion functions in stack, but loops doesn't have any stacks. About condition, if there is no termination condition, it can be an infinite recursion. However, if the condition never becomes false, it will be an infinite loop. This is another difference between recursion and loops. Space complexity. Moreover, the space complexity of recursive program is higher than the loop. And we have code readability. Another difference between recursion and loop is that a program with recursions is more readable than a program with loops. At the end we have a conclusion. The difference between recursion and loop is that recursion is a mechanism to call a function within the same function, while loop is a control structure that allows executing a set of instructions again and again until the given condition is true. Okay, now let's have some examples of recursion functions. Okay, first we have an example by the name of capitalized words. Capitalized word. Before we are going to solve this, we have to be focused on three things in recursion. One of them is recursion phase, recursive case. Next one we have base case and international case. We can say for this a constraint. Okay, first we make a function by the name of capitalized words. Here we have one parameter, and first we have recursive case. Recursive case is like this: to return result, first we create a variable by the name of results. We have return result dot append all parameters in R. First index become upper in uppercase, and here we have a word list. I am learning recursion function. Now if we print from capitalized words the word, let's see what happened here. Okay, it displayed none because we just here make a recursive case. Now it's time to make the base case also here. Now we return result dot plus capitalized word from array 1 up to n. It can be slicing from 1 up to end of the list. Again, let's check it. Yes, again we don't have any things, and the result can be none because we didn't focus on the constraint. Here we have a if statement. If length of array or the list should be 0, please return the self result. Otherwise it will return results plus. Now let's run it. Again it's split none. I don't know what's the problem. We have return. We should clean this because we don't need to return again here. Now if we see all the words be and capitalized. If we make the first of each words make capitalized, how we make it? First, let's change the name of the function. Capitalized first. Now we should change also here first. Capitalized first. Again we should change this also here. Now in array of 0 we start from 0 to 0 the upper and plus list of 0 up slicing 1 at the end of it. Now if we see just the first word or become capitalized. Yes, I am learning, the L is capitalized, recursion capitalized, functions capitalized. Okay, let's come to another function by the name of how to collecting the string, collecting string. First again we have a function by the name of collecting string. Inside of that we have one object. And first we have an empty list, a variable by the name of result array. Now we have a for loop for key in object, and if the type of the object is the key, if the type of object is in list and star, result should be dot append object of the key. Or if type of object key is the dictionary, again the result equal to result or plus from calling the function collecting strings object of the key. Now here we have return result. Here we have an object equal to, we have stuff by the name of foo. Here we have data equal to, inside of data we have a val, again inside of val we have things, and inside of things we have info that is equal to bar here we have another by the name of more info. Inside of more info we have even more info, again we don't have here. Here we have we made it equal to pass. Now here we call our objects. We have print by the name of collecting strings inside of object. Now guess that what's be displayed here. It should be displayed the phone, the bar, and the bus. That should all store inside of dictionary. Now let's run it. Yes, the bus, the bar, and the phone. It was about collecting objects. Now let's come to another example by the name of factorial. We have factorial. Again we have a function by the name of factorial. Inside of factorial we have a number parameter, and here first we return num multiple factorial that become loop and -1. Here we call the function factorial, print factorial 4. That should be equal to like this: 1 multiple 2 multiple 3 and multiple 4. That should be equal to 24. Again, if you run it, we have a problem because we don't have here any constraint. Let's make the constraint, because the factorial equal to, if the num of factorial equal less than equal to 1, it returns with 1. Now if we run it, yes, it's worked completely. The factorial number 4 is 24. If we put 5, it should be changed to 120. Okay, it was about factorial. Let's come to another example by the name of Affinity. We have Affinity program. If the Affinity program is like this: from 2 variable is the sum of the next one. Let's code it. We have a function by the name of fib. We have a function Affinity. We have again parameter here, and if let's first make the recursive case, return from FIB nums -1 and plus FIB num -2. If we return 4 from FIB, the 4, okay, sorry, we should be print again. It gives error because we don't have the constraint here. Let's make if the num equal to 2. It gives again, it should be returned the num. Now if we run it, yes, 3. If we have write 10, the number should be 55. It was about Affinity. Okay, sorry, just we comment the print, the others was no problem, it'll be here. Okay, this is enough, as I think. I hope that you enjoyed from how to work with recursion functions, and for the next video, goodbye.